All right, everybody. Week 7 mathematics. I know you're excited. It's hard to contain, but you're going to have to, okay, for the next 15 minutes or so. Contain your excitement and learn as much as you can. The topic for this week with writing is writing exponential equations. It's still focusing around the same stuff that we've been doing, but we're going to be talking about writing the equations from the table or from a graph that we're given or things like that. So it's kind of working backwards a little bit. So should be pretty simple. In fact, maybe midweek I'll throw something else at you just for funsies or something like that. But anyway, for right now, let's take a look at writing exponential equations. Let's say that you were given 2 points and you know that it is from an exponential equation. So specifically, it's from an exponential equation. That's important information because if I just give you 2 points and you don't know whether it's exponential or whether it is linear equation, then you would have to choose the right equation, right? Because if I said that these 2 points were from a linear equation, then you would do, y2 minus y1 over x2 minus x1. That would give you your slope. You plug that in to find your starting value, blah, blah, blah. But if you know that it's an exponential equation, then you're going to treat it differently and you're going to put it into a different equation. So if we had it as a linear equation, we can plot these 2 points right here, and then we would know that the line would just go, boom, straight down. That's simple. You guys have done that. A linear equation is a straight line between 2 points. Done. But if it's an exponential, we know it's curving. And so then the question is, where does it curve? Does it curve like right away? Or does it curve way down here? You never know. Well, you do know, but we got to figure that out. So this would be a linear equation, right? It drops 5 over 1, so therefore, hey, y equals mx plus b. Our slope is going to be negative 5 over 1, and then the y-intercept would be how far up the y-axis it is, and it's on 5, so therefore, there you go. Okay, done, simple as that. Now, exponential equation, slightly different. Same 2 points, we plot them there, okay, and again, we don't know where it curves or anything like that. We're going to need to know more information. Essentially, we're going to need to know more points that it's going to go through, okay? So this is our exponential equation. Y equals a times b to the x. Remember, a is the starting value, just like our y-intercept over here. Now, I know it's confusing. Y-intercept is b in this one, and essentially the y-intercept or the starting value is a in this one. I know it's confusing. I'm sorry. It's not my fault. But, that's just the way it goes. So, y equals a b to the x. So, y is the starting value, b is our constant ratio, or you could think of it as the multiplier, okay? And there we go. So, and remember the y and the x, okay, in these equations, both of these equations, this equation over here and the y and the x over here, they are both the coordinate values, right? The coordinate, the ordered pair. That's where the y and the x are. So those will change based off of the points. So in this case, we know that the starting value is going to be 5. Boom. We've got one of the points that are one of the parts of the equation that we need to put in there because the starting value is the same. It's 5. 5 here, just like it is over there. Okay, starting value. Now we need to figure out our multiplier. Okay, that is the last thing that we need to figure out. Let's think for a second about equations. If you want to solve an equation, you need to have one missing value. You want to only have one missing value. It gets a lot harder if you have 2 missing values. So is there a way that we can plug something into this equation that will only leave us with one of these variables? We have a y, a b, and an x remaining. Can we is there anything we can plug in here? Hopefully you're looking up here at the points that we have, either of these two. Okay, they're also written up here. We could plug either of these points into this equation, and it will help us out. Okay, so I'm going to choose to plug in this one. Okay, I'm not going to choose to plug in this one here. You could, but you're going to get a lot better information over here. So 10 and negative 1 are the points, right? 10 is the y, negative 1 is the x. So 10 goes here, negative 1 over there. Start solving it. It's pretty basic, right? There's only one variable here, so all we got to do is just start solving it out. So we're going to divide by 5. Okay, so we get 2 equals b to the negative first power. What are we going to do here? Okay, well, change this right here into a proper form. So b to the negative first power would be 1 over b to the first power. Okay, remember how we did that? Whenever you have negative exponents, it doesn't make the answer negative. You just flip the fraction over, right? You put 1 over this, and the power becomes positive down here. So 1 over b to the first. Now, in this case, all we have to do is multiply by b on both sides. 2b equals 1, divide by 2, therefore we get 1/2. Okay? So we get our multiplier right here is 1/2. So that goes right there. We now officially have our equation, right? Y equals 5 times 1/2 to the x. Okay, there it is. That's all we need to have. Now, is this line perfectly accurate? No, this line is not perfectly accurate. It can be close, it can be off a little bit, that's okay. I created this just after we were done with it. The important part was writing the exponential equation, hence the name of the lesson today. The name of the lesson wasn't draw the line perfectly. So let's try something else here. We've got these 2 points. Okay, remember the first column is going to be x, second one is going to be y. We don't mess around with that. We don't typically switch those around just to get people confused because that would be a little bit crazy. So here's the thing. If you know that they are points from an exponential equation, then you can use an exponential equation, right? It seems kind of silly. If you know they're from an exponential equation, use an exponential equation. But again, it's important information, like I was saying before, because if we had these 2 points and they were in a linear equation, then you got to use this one. But if they're in an exponential equation, you got to use this one. So that's why, we put this information there. Make sure that you know what it is, okay? If it doesn't state it, that's information you have to know. You might, if it doesn't tell you, you might end up saying, okay, well, if I solve it as a linear equation, here you go. If I solve it as a exponential equation, here you go. But don't worry, these ones are going to be exponential equations. So with that information, what we can do here is we can actually try and possibly find our, not just the starting value, but we might be able to find our multiplier here. Just depends. This is, and I'm going to back up here. I said that the x's were here and the y's were here. I apologize. I did not mean that the x's were here and the y's were here. In this table, the x's are on the top and the y's are on the bottom. So that's Mr. Reinhardt's fault. You can rewind and replay that part and call me an idiot, but there we go. The x's are on top and the y's are on bottom. So as the x changes, how much does the y change? Okay, so we've got that. Now notice down here, it's an exponential equation. I did not write that the y goes up 16 because again, in an exponential equation, the y is changing by a multiplier, not by an addition. So I'm not going to figure out, what's 20 minus 4. I'm going to figure out what can I multiply by 4 to get 20. So it's a multiplier here, okay? So what I've actually got is I know my multiplier, right? I know my multiplier. My multiplier is going to be 0.5 because as every x value changes by 1, my y value is going to change by 0.5. So I could actually write out my equation right here, okay? And we will verify that the multiplier is correct. So let's plug in one of the points. We got 20 and 1. So I'm going to plug in those. The 20 goes here. The 1 goes here. We know that it starts at 4, right? Because the 0 is the starting value, right? When x is 0, y is 4. So there we go. Start solving. Okay. Divide both sides by 4. B to the first power. We don't change this. Anything to the first power is just itself. So we're just going to get rid of the 1, or the first power, and it's 5. Hey, look at that. 5. So we have verified that our multiplier that we found from up here is actually the multiplier. Okay. Not all of them are going to give you points that are consecutive, by the way, because if this went up by 2 and this multiplied by 5, then it is not going to be the same thing as just, it's multiplied by 5. So you got to make sure you check that, okay? All right, so let's do it again. Don't forget to write out the actual equation, 4 times 5 to the x, okay? Now, remember, we can replace this y with f of x, okay? It's a function notation. It means the same thing, so don't forget that you can do that. Okay, so up here, can we find our multiplier looking at our 2 points? Remember, x's are on top and y's are on the bottom. Can we find our multiplier? Take a second. As the x changes by 1, the y, remember, it's not an addition, it's a multiplier, so it goes up by multiplying by 4. So let's verify that our multiplier is 4. And then also, what else do we not know by looking at this? Take a look at this one, take a look at this one again, look back at this one, and now this one, like the Old Spice commercials. Anyway, we don't have our starting value, right? There's no x as a 0, so therefore we don't know the starting value. So we need to plot these 2 points, or put one of the points in here to figure out what it is, and then we can start plotting. Okay, we could put 3 and 10 and 4 and 40. That's fine, but it's not going to give us much information. So, this is just me goofing off and seeing if that's going to work out. Let's see here. So, We're going to plug in notice that we've got our multiplier is 4, so we're going to put that in there. Since we know that if it's going up by 1, then our multiplier here is correct. Is this going up by 1? Yes, so our multiplier here is going to be 4, so we know that should work, so we're going to plug that in. And then we're going to use the point 10 and 3. Okay, you could use 4 and 40, it's up to you. But I'm using 10 and 3. So 10 goes here where the y is, 3 goes where the x is. And then we're going to start solving it out. What is 4 to the third power? Well, it's going to be 64, so then we're going to divide both sides by 64, and this is going to reduce down 5 over 32. I know you don't like fractions, but get used to them. Fractions are okay. They don't need to be feared. It's going to be all right. So now what we have is our starting value of 5 over 32. Notice that I kept it as a fraction. There was no need to put it as a decimal. I didn't need to have it written in decimal form just so I could put this in the right spot. I just needed to have a number. Right? Because again, this is not going to be 100% accurate because I'm a human and I drew this myself. Is it possible, are you going to be more accurate putting 5/32 on your graph or the decimal equivalent of it? Okay, so it's not really the big deal here because it wasn't necessarily about graphing it. It was about finding the equation. Okay, so that was the important part there. All right, let's take a look again here. What if we have a situation like this? We have a table, we've got two numbers, or two ordered pairs here, but we notice that they're separated, right? -3 over 24 and 0 over 3. We don't have these values in here. Do you think we can fill this in and find these values? Well, yeah, we can. So let's take a look here and see what we could do. We've got, if you look at this, if you want to isolate the 2 points that we have, -3 over 20, or -3 and 24, remember these are the x's, and then 0 and 3, then it could look a lot like this one, essentially, where we have our starting value, right? We have an x is 0. Okay, that's important. So we can plot that point here, or, wherever it's going to be, so right up in here. Okay, actually 1, 2, 3, there we go, right there. And then we can plug in the other point in the information there. So let's do that. 0, 3, and it looks like I'm choosing to make each of these bars here worth 3. Okay, that just makes it easier because we got to go up to 24. So 3, 6, 9, 12, you get the idea. Okay, so plug the points in here. So I'm going to choose this one, -3 over 24. And what we get here is or not over 24, but -3 is the x and 24 is the y. So there we go there and right there. Start off by dividing both sides by 3. Okay, get rid of that. It makes it much simpler, right? Now we're going to do what with this? What do you guys remember that we do with this? This is b to a -3rd power. Well, we will write it in the correct form, so we're going to make it 1 over b to the 3rd power. And then what we do is we're going to try and get this away from the bottom. So we're going to multiply both sides by b to the 3rd. Notice that cancels out, leaving it with a 1, and then we've got 8 times b to the 3rd. Okay, back up and take a look at that one again just to make sure, and slow it down or hit pause, try and solve it yourself. Okay, because that's an important thing. But just multiplying by b to the 3rd over here gets rid of it and moves it over here, and now it's not in the bottom of a fraction. And it's not easy to solve it when it's in the bottom of a fraction. We have to do this. So, and then all I'm doing is moving it up here so I got more room. Okay, so now that we're in this part, I'm going to divide both sides by 8. Okay, that leaves me with b to the 3rd power equals 1/3. Well, this is what I get for trying to make videos when I'm not awake, really. In the video, I clearly said that 1 divided by 8 was 1/3, and hopefully everybody caught that was incredibly, ridiculously dumb. Obviously, 1 divided by 8 is not 1/3, it's 1/8. And then when you find the cube root of 8 is 2, and that's why you get the answer of 1/2. So hopefully you found that mistake, and I apologize. And then we will take the cube root. Yes, we will take the cube root, right? So that will cancel out this over here, so we end up with b, and then we just need the cube root of 1/3. Well, the cube root of 1/3 ends up being 1/2. Okay, so you can solve that in your calculator, but there you go. Y equals 3 times 1/2 x, or 1/2 to the x, okay? Now, I know this went quick, but again, you guys have a pause button. You guys get to do that, so don't forget, go back, take a look at it again. You got the notes written down, and don't forget, email me if you got any questions, okay? It's all good. Hop on the video chat, that sort of thing. What I did over here was I just filled it in. If I know that my multiplier is half, then I'm going to multiply this by 1/2 essentially. So 24 times half is 12, times half is 6, times half is 3. Okay, and it works out. Okay, and then I could fill in the numbers here and, I could fill in the numbers here if I wanted to and draw it. Okay, so I'm going to tell you something that in the homework, what you're going to see is graphs. Okay, it's not going to give you the table, it's going to give you the graph. And so you're really going to want to try and zoom in if you've got it digitally, or look really closely if you've got it on paper, and you will be coming up with these points. Okay, you need to get these points from the graph that is drawn. So in the homework, the graph is drawn for you. You will find the points that are in there, use the points that you have from the graph, and then try and come up with the equation. So it's a little bit interesting where it doesn't specifically give you points. So what I'm going to say is you're not going to want to try and find a point that's right here, okay, where the tip of the arrow is in the middle of it. You want to find it where it crosses the grid lines, okay? So where it crosses the grid lines, and again, this one right here, not going to be a good choice. This one here, no, 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 no. This one, yes. Okay, that's what you want to look for, is where you have the graph crossing an intersection on the grid, okay? And that is going to be a point that you can use. And remember, you've got strategies that it doesn't matter if it's the starting value, okay? If you can't tell what the starting value is, like this one, the starting value is 5/32. You can't specifically determine that that's what it is, so don't use it. Over here, you can, because the starting value is on an intersection, okay? So just remember, look closely. It's not obscure numbers. It should be whole numbers, obviously, for the points, so you should be able to figure it out, okay? But again, if you have any questions, shoot me an email, hop on the video chat. I've got the phone number that you can call. It's going to be good. We got a couple weeks left, and yeah, we'll have a good time. So enjoy yourselves this week, and we will see you soon.